All right, let's consider a permutation if we do have repeated objects. So if we have a set of n objects and there are k identical objects. So a classic example of this would be like a word that has repeated letters. So we're going to look at an example with hello. Hello has different letters H, E, L, and O. So in this case, there would be 4 subsets of identical objects. We only count the L once but it shows up twice. So that's what we mean by a subset of identical objects. These are the things that get repeated within your larger set of n objects. We're going to let R sub 1 be the number of objects in subset 1. R sub 2 will be the number of objects in subset 2, etc. And then the way we figure out the number of ways to permute these different objects, even though we have non-distinct ones, is by taking n factorial divided by r1 factorial, r2 factorial, etc. down to rk factorial. So let's see how we would apply this with the letters in the word hello. We want to know how many ways are there to arrange the letters of the word hello. So H shows up only once in the word hello, so we have one of them. E shows up only once, but L shows up twice, and O shows up only once. So if we want to rearrange hello to make a different arrangement of these letters, it shouldn't matter if I take this L versus this L. If I put an L, then it still represents an L. And so that's what this formula for permutations with repetitions is going to account for. So I want to figure out how many different ways can we arrange this. And so let's see. Our n is the total number of objects. So in this case, n would be 5. And I'm going to let 1, so I'm going to call H like my first subset. So 1 would be R1. E is my second subset, that would be R2. L is my second subset, so that 2 would be R3. And then O would be my fourth subset. It's the type of letter that determines the subset. So let's see. So if we want to figure out how many different ways to rearrange this, we will take 5 factorial, and we divide it by 1 factorial times 1 factorial times 2 factorial times 1 factorial. I forgot my 1. 1 factorial. There we go. So let's go ahead and simplify. 1 factorial times 1 factorial times 1 factorial, that's all just 1 factorial. So we really have 5 factorial over 2 factorial. And we know that the 2 factorial will divide out everything after 3. So we're left with 5 times 4 times 3, which would be 60 different ways. So there are 60 ways to rearrange the letters in H-E-L-L-O. We're using all 5 letters in these rearrangements, but it's just the different ways that you could rearrange them. They don't necessarily make a word, they're just rearrangements of those letters. Okay. So anytime you have repeats, you want to be using this formula for permutations with repeats. Let's take a look at another example here. So we have a scout troop, Troop 456. They have 22 members. And the scoutmaster is going to appoint a crew of 5 different members. There's going to be this should say a leader. There's a leader, a chef, and a cleanup crew with 3 scouts. How many different crews are possible? So in this case, we have a combination of the different techniques. So in some cases, the order matters because we have titles. We have a leader, we have a chef, but within the cleanup crew, the order doesn't matter. There's no leader for the cleanup crew. It's just that there are 3 scouts who are in charge of the cleanup crew. So this means we're going to have to use both a permutation and a combination. So there's a couple different ways that we could do this problem. The way that I sort of think of it is, first, I'm going to choose my 5 scouts. I'll choose my 5 scouts, and then once I have those 5 scouts, then I can organize them into a leader, a chef, and a cleanup crew. So then I can organize them. Now, within my 5 scouts, this is what my set would look like. I would have a leader, I would have a chef, and I would have a cleanup, another cleanup, and another cleanup. So this would be an example of a set with repeats. We do not have 5 distinct objects. We have 3 distinct objects, and the cleanup crew is repeated 3 times. So to choose the 5 scouts, we are choosing the 5 scouts from the 22 distinct members. So this would be the combination of 22 members into groups of 5. It's a combination because it doesn't matter. I'm not assigning the title when I choose the scouts. I'm just picking the 5 scouts. Then when we organize them in step 2, this is where we'll be assigning the title. So to organize them, this would be a permutation with repetition. So we'll think of the leader, that's one subset. So my R1 would have size 1. A chef is a second subset. There's still one of those. And then the cleanup crew, that's my R3. There are 3 of them. So to figure out all the different ways that we could organize those 5 scouts into leader, chef, and cleanup crew, we will do the permutation of 5 elements where we have some of them repeating. So that would be a 1 factorial in the denominator, a 1 factorial, and then a 3 factorial. And so let's see. Our first combination, we have 22 factorial over 5 factorial times 17 factorial. And the second permutation, the one with repeats, would just become 5 factorial over 3 factorial. Simplifying our first factorial, we end up with 22 times 21 times 20 times 19 times 18, all divided by 5 times 4 times 3 times 2 times 1. And then this is multiplied by 5 factorial, but we can simplify the 5 factorial, right, with the 3 factorial, in the denominator. That would be just 5 times 4. And so multiplying this all out, you can also, start to simplify. 5 divided by 5 gives us a 1. 4 divided by 4 gives us a 1. 3 goes into 18 6 times. 2 goes into 20 10 times, etc. You can simplify, and we should end up with 526,680 different ways that we could choose 5 scouts and then assign them to a leader, a chef, and a cleanup crew. Okay. All right, so let's see. We can use combinations. We can do permutations. We can do combinations with permutations. We can do permutations that have repeats. We can pretty much count, most things at this point. Okay. So the key thing to recognize when you are trying to count something new: does the order matter or not? And then are there any repeating terms or not? And then that sort of lets you figure out how you want to proceed from there. All right, that's all for now. Until next time.